Clammus sweetus is a newly discovered species of clam. It had gone undiscovered until recently due to its small size and the remoteness of the area it inhabits. Two symmetrical shells connected by a hinge joint protect its soft body. C. sweetus, like other clams, eats plankton and in turn is eaten by small sharks and squid. In order to better understand C. sweetus and how it has changed over time, it is important to study variations present within the population. Your container labeled C. sweetest strain M holds 10 individuals. Without removing them from the bag, observe any traits you could use to accurately describe the appearance of this organism. Your container labeled C. sweetus strain R also holds 10 individuals. Without removing them from the bag, observe any traits you could use to accurately describe their appearance. Based on your observations, are there any distinct differences between C. sweetus strain M and strain R? Additional observations of variations within the C. sweetus species require that different tests be performed on the clams. For example, you cannot tell if one clam has a stronger shell than another by just looking at them. To find this out, tests must be conducted. Select one C. sweetus M and one C. sweetus R and place them as a pair on the appropriate circles in Chart 1. To determine which clam has the strongest shell, we are going to place all 10 pairs in the appropriate spot. The first pair of C. sweetus strain M and strain R clams. Stack one on top of the other as illustrated in Figure 1. Hold the two clams so that your thumbs are on the bottom surface and your index fingers are placed securely on top. Evenly apply pressure to the top and bottom of the stack. As soon as one of the shells cracks, stop. Examine the two specimens and determine which one cracked first. The least cracked shell represents the survivor. Indicate the survivor by recording the appropriate letter in the circle in the strain of survivor column. If it is impossible to determine which clam cracked first, record the one whose shell cracked the least in the strain of survivor column. Repeat the above procedure a total of 10 times. survivors. We're now going to pause the video to give you an opportunity to answer questions 4 and 5 in your breakout groups. A research team investigating the impact of the predatory arthropod on the C. Sweetus population hypothesized that shell color and hardness are related. To test this hypothesis, the team suggested that they conduct an experiment similar to the one done in part 1. This time, only C. Sweetus strain M is used, and the pears being crushed always consist of 2 different colors. Select individuals from your C. Sweetus strain M part 2 container and place them on the appropriate circles on chart 2. Positioned on the chart, begin this part of the investigation by stacking a yellow and blue clam and applying pressure. Indicate which has the hardest shell by recording the appropriate letter in the circle in the color of hardest shell column. Next, repeat the process using a yellow and an orange clam. Continue to work down the chart until all of the pairs have been tested and the data recorded. Data in chart 2. Use chart 3 to summarize your findings. We will now pause the video for you to work in your breakout groups to fill out chart 3 and the remaining questions in this packet.